Inferences for two population means. Using independent samples, standard deviations not assumed equal. Distribution of the non-pooled t statistic. Suppose that x is a normally distributed variable on each of two populations. Then, for independent samples of sizes n1 and n2 from the two populations, the variable t equals, in the numerator, open parenthesis, x bar sub 1 minus x bar sub 2, close parenthesis, minus, open parenthesis, mu sub 1 minus mu sub 2, close parenthesis. In the denominator, square root s sub 1 squared divided by n1 plus s sub 2 squared divided by n sub 2 has approximately a t distribution. Distribution of the non-pooled t statistic. The degrees of freedom used is obtained from the sample data. It is denoted delta and given by delta equals, in the numerator, open parenthesis, s sub 1 squared divided by n sub 1 plus s sub 2 squared divided by n sub 2, close parenthesis, squared, all over, in the denominator, first fraction is s sub 1 squared divided by n sub 1, all of that squared, divided by n sub 1 minus 1, plus the second fraction, s sub 2 squared divided by n sub 2, all of that squared, divided by n sub 2 minus 1, rounded down to the nearest integer. Non-pooled t-test. Purpose: to perform a hypothesis test to compare two population means, mu sub 1 and mu sub 2. Assumptions. 1. Simple random sample. 2. Independent samples. 3. Normal population or large sample. Non-pooled t-test. Step 1. The null hypothesis is h sub 0 colon mu sub 1 equals mu sub 2, and the alternative hypothesis is h sub a colon mu sub 1 does not equal mu sub 2, two-tailed, or h sub a colon mu sub 1 less than mu sub 2, left-tailed, or h sub a colon mu sub 1 greater than mu sub 2, right-tailed. Step 2. Decide on the significance level alpha. Step 3. Compute the value of the test statistic and denote that value of the test statistic t sub 0. T equals, in the numerator, x bar sub 1 minus x bar sub 2, in the denominator, square root s sub 1 squared divided by n sub 1 plus s sub 2 squared divided by n sub 2. Non-pooled t-test using critical values. Step 4. The critical values are plus or minus t sub alpha divided by 2, two-tailed, or negative t sub alpha, left-tailed, or t sub alpha, right-tailed. Use the t-distribution table to find the critical values. For a two-tailed test, our rejection region is to the left of negative t sub alpha divided by 2 and to the right of t sub alpha divided by 2, and each area is alpha divided by 2. For a left-tailed test, the rejection region is to the left of negative t sub alpha, with the rejection area being alpha. For a right-tailed test, the rejection region is to the right of t sub alpha, with the rejection region being alpha. If the value of the test statistic falls in the rejection region, reject h sub 0. Otherwise, do not reject h sub 0. Step 6. Interpret the results of the hypothesis test. Non-pooled t-test using p-value approach. Step 4. The t-statistic has with degrees of freedom equal to delta, where delta is rounded down to the nearest integer. Use the t-distribution table to estimate the p-value or obtain it exactly by using technology. If the p-value is two-tailed, the rejection region is the area to the left of negative absolute value t sub 0 plus the area to the right of absolute value t sub 0. Left-tailed, the p-value is to the left of t sub 0. Right-tailed, the p-value is to the right of t sub 0. Step 5. If p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. Step 6. Interpret the results of the hypothesis test. Non-pooled t-interval procedure. Purpose: to find a confidence interval for the difference between two population means mu sub 1 and mu sub 2. Assumptions: 1. Simple random sample. 2. Independent samples. 3. Normal population or large sample. Step 1. For a confidence level of 1 minus alpha, use the t-distribution table to find t sub alpha divided by 2 with degrees of freedom equal to delta, where delta is rounded down to the nearest integer. Step 2. The endpoints of the confidence interval for mu sub 1 minus mu sub 2 are, open parenthesis, x bar sub 1 minus x bar sub 2, close parenthesis, plus or minus t sub alpha divided by 2 times the square root of s sub 1 squared divided by n sub 1 plus s sub 2 squared divided by n sub 2. Step 3. Interpret the confidence interval. Choosing between a pooled and non-pooled t-procedure. Suppose you want to use independent simple random samples to compare the means of two populations. To decide between a pooled t-procedure and a non-pooled t-procedure, follow these guidelines. If you are reasonably sure that the populations have nearly equal standard deviations, use a pooled t-procedure. Otherwise, use a non-pooled t-procedure. Example using critical values. Preliminary data analysis indicate that the assumptions for using non-pooled t-procedures are satisfied. Researchers obtained the data shown in the table on the number of acute post-operative days in the hospital using the dynamic and static systems. At the 10% significance level, do the data provide sufficient evidence to conclude that the mean number of acute postoperative days in the hospital is smaller with the dynamic system than with the static system? Note, x bar sub 1 equals 7.92, s sub 1 equals 1.73, x bar sub 2 equals 9, s sub 2 equals 3.16. Our data for the dynamic systems 5, 8, 5, 10, 10, 8, 7, 8, 8, 10, 7, 9. The static system data 7, 8, 6, 7, 13, 13. We want mu sub 1 to equal the dynamic systems and mu sub 2 to equal static. We also know that the dynamic system n sub 1 has 12 pieces of data. The static system n sub 2 has 6 pieces of data. Step 1. Find h sub 0 and h sub a. H sub 0 is always mu sub 1 equals mu sub 2. Next we want to find h sub a. Because we want to show that the days in the hospital is smaller with the dynamic system than with the static system, H sub A is mu sub 1 less than mu sub 2, which means we have a left-tailed test. Alpha is to the left of negative T sub alpha. Step 2, we want alpha. Since it is 10%, alpha equals 0.1. Step 3, compute the value of the test statistic and denote that value T sub 0. We want to go to our calculator, Stat over to Tests. We want number 4, to sample t-test. We have statistics. X bar sub 1 is 7.92. S sub 1 is 1.73. N sub 1 is 12. X bar sub 2 is 9. S sub 2 is 3.16. N sub 2 is 6. It is a left-tailed test, so I want to highlight less than mu sub 2, enter. It is not pooled, enter. Go down to calculate, enter. T equals negative 0.7807. Rounding to 3 decimal places, the test statistic is T equals negative 0.781. Step 4. Identify the critical value with degrees of freedom equals delta, where delta is rounded down to the nearest integer. We're going to find delta using our calculator. Our degrees of freedom are 6.544. So if delta is about 6.54, our degrees of freedom will be 6. I am now ready to find negative T sub alpha. Alpha is 0.10. Going to my t-distribution table, I want row 6, and I want T sub 0.10. And on my table, it's 1.440. Because it is left-tailed, that equals negative 1.440. The critical value is T sub alpha equals negative 1.440. Step 5. If the value of the test statistic falls in the rejection region, reject H sub 0. Otherwise, do not reject H sub 0. So I want to locate the test statistic and the critical value on my sketch. The critical value is negative 1.440. My test statistic is to its right, negative 0.781. That is in the do not reject H sub 0 region. Do not reject H sub 0, the null hypothesis. Step 6, interpret the results of the hypothesis test. The data do not provide sufficient evidence to conclude that the mean number of acute postoperative days in the hospital is smaller with the dynamic system than with the static system. Example, using p-values. Provided below are summary statistics for independent simple random samples from 2 populations. Use the non-pooled t-test and the non-pooled t-interval procedure to conduct the required hypothesis test and obtain the specified confidence interval. X bar sub 1 equals 13, S sub 1 equals 2, N sub 1 equals 10, X bar sub 2 equals 10, S sub 2 equals 7, N sub 2 equals 15. Right-tailed test alpha equals 0.05. Step 1, find H sub 0 and H sub A. As always, H sub 0 is mu sub 1 equals mu sub 2. Since this is a right-tailed test, H sub A is mu sub 1 greater than mu sub 2, And our sketch will be of a right-tailed test where the p-value is to the right of t sub 0. Step 2, decide on the significance level alpha. We are told in the problem that alpha is 0.05. Step 3, compute the value of the test statistic and denote that value t sub 0. We want to use our calculator to find this. Stat, over to tests. Number 4, 2-sample t-test. We want statistics. X bar sub 1 is 13. S sub 1 is 2. N sub 1 is 10. X bar sub 2 is 10. S sub 2 is 7. N sub 2 is 15. We have a right-tailed test, so I want to choose greater than mu sub 2. Enter. It is not pooled, so I want to make sure no is highlighted. Calculate. Enter. We are looking for our t-value, which equals 1.566698904. Rounding to 3 decimal places, the test statistic is t equals 1.567. Step 4. Use the t-distribution table to estimate the p-value, or obtain it exactly by using technology. If you need delta, that's our degrees of freedom rounded down to the nearest integer. We can find the degrees of freedom by going to our calculator. Our degrees of freedom were 17.236, which means delta is approximately 17.24, and rounding down to our nearest integer, the degrees of freedom would equal 17. Going back to our calculator, also have p equals 0.067679604. Rounding to 4 decimal places, the p-value is 0.0678. Step 5, if p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. We want to compare p to alpha. P is 0.0678. Alpha is 0.05. 0.0678 is greater than 0.05. The p-value is greater than 0.05, which means we do not reject h sub 0, the null hypothesis. There is insufficient evidence that mu sub 1 is greater than mu sub 2. Continuing with our example, find the 90% confidence interval. Going to our calculator, stat, over to tests. We want 0, 2-sample t-interval. We have statistics. It brought over our statistics, arrowing down to C level. The C level, our confidence interval is 90%, 0.9. Pooled, no. Calculate, enter. Our confidence interval is at the top, -0.3285 to 6.3285. Rounding to 3 decimal places, the 90% confidence interval is from -0.332 to 6.332. To recap, inferences for 2 population means using independent samples. Standard deviations not assumed equal. Distribution of the non-pooled t statistic. To find the t-value for independent samples of sizes n sub 1 and n sub 2, T equals parentheses x bar sub 1 minus x bar sub 2, close parentheses, minus parenthesis mu sub 1 minus mu sub 2, close parenthesis, all over the square root of s sub 1 squared divided by n sub 1 plus s sub 2 squared divided by n sub 2. We find the degrees of freedom by using the formula for delta, where delta is rounded down to the nearest integer.